Hello, my name is Dr. Gajendra Purohit and you are watching YouTube channel where I upload videos for engineering mathematics B.Sc students. If you are preparing for any competitive exam where higher mathematics is asked, then our YouTube channel is very helpful. I have started the Numerical Analysis, the 2.0 series where I uploaded video on error and approximation. So today I am going to talk about numerical operators here and about their relations, like what is a forward operator and what is a backward operator. What is a central difference operator? What is shift operator? What are identity operators? Plus, what is factorial notation? There are many new things we are going to learn, which are in the upcoming videos, where I will be discussing about interpolation. Plus, if we talk about numerical integration or numerical differentiation, then there is a lot of use for all these things in this. Stay tuned, and if you haven't watched my previous videos, you can go to IIT-JAM and watch them. Link is in the description. Now let's begin. Let's talk about forward difference operator. In forward difference operator, we write it here with del, right? Del of fx. Clear? This means that this is the f, x plus h minus fx. So this is called the forward difference operator. Clear, students? Normally, if you want to find the difference operator of any function, what do? First, we subtract it from the bigger term, right? That is known as a forward difference operator, right? Normally, we write this as a plus h minus fa. If you want to apply to a plus h, then bigger term is a plus 2h minus a plus h. About h, what is that here? It means step size. Okay, students. Or we call this as equally difference. Whenever we have any term there, then whenever we use this operator, we will use it only when we have any terms given in equal difference. Okay? Okay here. So we can use this operator here. Clear? So we have h, which is our step size. If we apply a plus 2h, this is how we apply it here. If we want to apply del square fx, then it does not mean its whole square. What will we do next? We will put del on it, del of del fx. Clear? So here, in all these places, del will be applied. It will be del fx plus h minus del fx, right? So the value of this will be del square fx, and here we will apply it. What will be big term here, students? Fx plus 2h minus from itself. Subtract this from itself, right, students? Okay. This will come minus, now apply it here. What will come here? F minus this from this bigger term, minus it from it. This will come, let's simplify this a bit. So, this will come fx plus 2h minus these two terms are the same. So, this will be minus twice fx plus h and minus minus plus fx. Here we have the value of this, clear? So, in this way we can understand this better, right? Now, let's move on, students. Next, we will talk about, I am trying to tell the same thing, that del square is not the square of del, right? This is the product of it we have, which means del over del, right? This needs attention. You see, there is a fundamental theorem for finite difference. Here, what does it mean? That if we have any n degree polynomial of this type, and if we have to apply the n difference operator on it, the value of this is a0 n factorial h power n, right, students? This is what we have. For example, if you are asked to apply x square on del square. So, students, the value of this is what we have. It is 2 factorial, and here this will be h power 2. You need to understand this. Is it clear now? Ultimately, it works like a differentiation in a way. For example, if you are told that del square is x, in that case, its value will become 0. That means whenever we have a small degree, we make it 0. If we are asked about its value, how do we calculate it? Such questions come in exams like del power 6, and this is what we have. So, ax minus 1 into bx square minus 1 into cx cube minus 1, and here they are asking you what is the value of h. It's 1. So what we will do? First we multiply this, right? So del power 6 I will leave as it is, and I will multiply this inside, right? This will come inside. So what is this? It's bcx power 5 minus bx square minus cx cube plus 1. This is the value here, and then multiply it. So when this is multiplied by this, it will be abc x power 6, right? When this x is multiplied by this, let me just do it once here, okay? So here minus abx cube, right? And minus here we have acx power 4 plus ax is coming here right now. And listen, minus bcx power 5 minus minus will be plus bx square and plus cx cube minus 1. This is the value we will have here, students. Okay, is that clear? Now here, what we will do is, we will check the degree. So let's arrange this once and check it in the descending order, right, students? Here we have x power 5 coming, it will be minus BC x power 5. Now we will look at x power 4. Term of x power 4 we have here is minus AC x power 4. Now we will talk about x cube. So this will come as C minus AB. So see, x cube is here, then the degree of x square we are getting is coming to us as bx square, and plus this we have x minus 1. This is it. Right, students? Now I told you that when its degree becomes equal to this degree, then we will have its value right. What next? We will apply it as ABC is constant, A will come out. This will be del power 6x power 6. I told you that when this degree, this is smaller. In that case, whenever operator is applied, the value will be 0. All of these will be 0 here. We will have value of this here, and this value will be equal to what? BC, and this will be 6 factorial. And here it will be h power 6 because the value of h is given to us as 1, right? So we have 6 factorial, its value is 720 into ABC, and the value of h is 1. In this way, we can easily solve this type of question. So next, what is backward operator? We write it with nebula, right? To get the backward operator, then nebula for finding the value of fx, what comes here? Fx minus h, meaning this function here minus it from this and this. So what is it called? It's called backward operator. Okay, clear, students? So if you are asked to find the nebula square fx, what we will have, then it will be nebula of nebula fx, right? So in this fx, what are we going to apply? We will apply nebula. So it will be fx minus h. So this will be nebula of fx subtracted by nebula of fx minus h, right? What is the value of this? Here subtract this one from itself, minus 1. Now for this you need to pay attention here. And minus from here what will come? You have to subtract this from itself, minus 1, right? So here we will get its value for this. Clear? We will simplify this. So here this will come fx, and we will add these two. Minus 2fx minus h plus, here this will be fx minus 2h. Now a question might arise in your mind about nebula and del. What is the difference between them? Let me tell you about what is del. Pay attention here. In the forward operator, what happens in it? From big term, this will be subtracted. Pay attention to this. And what happens in nebula here? So in it, the big term which is there, we subtract that from fx by decreasing it by 1. You need to understand this here a little bit. This is the difference between the forward and backward operator. Clear, students? Here if we have a question given, for example, you need to find the nebula of tan x where the value of h is given as 1. What are we going to do here? We will calculate nebula of tan x. Okay, and the value of h is 1. So what do we do? This will be tan x minus h, and the value of h is 1. So this will be the value. Clear? What we will do? We can write tan as sin x upon cos x, right? Minus this will be sin x minus 1 upon cos x minus 1. Okay, now take the LCM of this. It will become cos x minus 1, and here then it will be sin x, cos x minus 1 minus. Clear, students? Cos x sin x minus 1, what will come? Sin a cos b minus cos a sin b. So the formula we have, what is it? Sin a minus b is the formula. This will be sin x minus 1. This is minus formula, which is divided by cos x. Cos x minus 1, cancel x from x, right? So you see that from here, we have the value of sin 1 cos x minus 1. So this will be the value of this here. Clear, students? Now moving on ahead. If we talk about identity operator, so identity operator means that if we have any given function, if we use this operator in that, then we will get back the same function. Identity operator means 1, we can say that, right? So ultimately applying this on that will not change the value of the function, right? After that we have a shifting operator. We denote this by e by shift. You understand that it means taking it to the next term. Like here a function fx is given, and if I apply the shift operator on it, what will happen? It will become x plus h. If I tell you that I am applying shift here 2 times, it will shift these 2 terms forward. So this would become x plus 2h. You need to pay attention. If I tell you that I am applying n, then what will this become? See carefully. Here this will be fx plus nh. You see that if I apply minus 1 here, then it will shift this backwards, right? So what will it become? It will be fx minus h. If I tell you e power minus 2, what does it mean? It means it is shifting it backwards 2 times, which means fx minus 2h. So you need to understand this, right? This is the shift operator. Now students, when we talk about shift operator here, the shift operator and the difference, meaning forward difference operator, these two have a relation in between. I will tell you about that relation. What did I tell you? I told you that the fx function we have that as fx plus h, right? And I said that if I apply inverse, then from here, what will be the value of this? It will be fx minus h. Now, if I say that I took forward operator del, right? And I applied del here and I applied fx. So, we know what this is. We have fx plus h minus fx. Clear, students? Now, what do I do? Here is del fx in place of x plus h. What can I write? I can write e of fx. And fx that we have here, I can apply identity of fx. I've applied identity operator there. If I remove fx, then del is equal to e minus I. This is a relation. Sometimes we write e as 1 plus del, right? So remember this, it's going to be very useful ahead. Here I am talking about nebula, that is backward difference operator. Then we will write it like this, students. Clear. What is the value of this? Here I told you, its value is of fx. Fx minus h, clear, students. We know nebula of fx. So what can I write this as I of fx? So what is this? What is the value of this? Its value is e of inverse of fx. Do you understand it or not? We have this. What we will do? We will remove fx, then nebula is equal to I minus e inverse, right? So this is also a relation that you need to remember. Okay, let's move on. So next, we will take an example here, and here it is asking you that what will be the value of e of fx square, where you are not told anything about h, right? So what do we know? We know that if we will apply a shift operator on it. So what will come? Wherever x is, there will be x plus h, and it's a square. So it will be x square plus 2xh plus h square, right? Its value will be, if we put value of h as 1, then in that case, it will be x square plus 2x plus 1. So another important operator which is widely used is the central difference operator, and it is denoted by delta. So what does delta mean? If we have any difference, any function on which this operator is applied. So what does it do here in this case? Fx plus h by 2 minus fx minus h by 2, right? So this is what we have, right? This is called the central difference operator, right? We use this by delta, okay? If I tell you that I told you about e of fx, what does it mean? Here it is fx plus h, clear? I told you that if I apply e square, then pay attention, what will come? Fx plus 2h. That means whatever power is there, it will come here. If we have 1 by 2 here, then what does this mean? So this will become e power 1 by 2 fx. Then we can write it like this, minus. This is minus 1 by 2 power, what will come? E power minus 1 by 2 fx. You understand this, right? Pay attention. Students, the value of del of fx, if I take fx out from here, then e power 1 by 2 minus, it will be e power minus 1 by 2 fx, clear? Do you understand? This needs proper attention, okay, students? Here if I write e power minus 1 by 2 as 1 upon e power 1 by 2, so what will come here? Pay attention, students. Del of fx is equal to, it comes out e power 1 by 2 minus 1 upon e power 1 by 2 into fx. If I take LCM of this here, then it will be the del of fx is equal to e power 1 by 2. It will be e power minus 1 upon e power 1 by 2 into fx will come. Clear, students? We know that there is a relation here that e is equal to 1 plus del. Then what do we need here? The value of e minus 1, e minus 1 value. This is I instead of 1. The value of 1 will be del. So students, this del of fx is equal to, this will come here as del upon e power 1 by 2 into, and here what will come, students? Here this fx will come. Is it clear now? Pay attention. This is something that you need to pay attention to. If we go there, then the relation that we have here with us, del e power minus 1 by 2. Clear? So here like this, we have a relation that needs to be understood. Sometimes in exam, they ask for a proof. So in this way, you can easily prove it here. So here I want to show you a good question. Like here you are being asked that, what is the value of del of tan x? What is he saying? Del of tan x, where the value of h is given as 1. Here, if we talk about the del of tan x, then here what is the value of del of tan x? So the value of del of tan x is tan x plus 1 by 2, right? Value of h is 1, x plus h by 2 is minus tan x minus h by 2. But the value of h is 1, then it will come as minus tan x minus h by 2, that is 1 by 2. Okay, clear, students? Now write it here. What will come? This will come to us sin x plus 1 by 2 upon cos x plus 1 by 2, right? Minus this will be sin x minus 1 by 2 upon cos x minus 1 by 2. Now take its LCM here. When we take the LCM, then it will be cos x plus 1 by 2 into cos x minus 1 by 2. So here, when we take its LCM, then this will become sin x plus 1 by 2 into cos x minus 1 by 2. Minus this will be cos x plus 1 by 2 into sin x minus 1 by 2. The above formula, which is sin a cos b minus cos a sin b, right? So this is sine A minus B. That is sine, this will be x plus 1 by 2 minus x minus 1 by 2. Clear, right? This is the formula, students. Here, this will be cos x plus 1 by 2 into cos x minus 1 by 2, right? Clear, students? Students, here, this x will cancel this x. So from here, our value will be sine 1 upon cos x plus 1 by 2 into cos x minus 1 by 2. So this will be the value of this here. We can easily prove it this way. So moving on, students, the next concept we have is the average operator. So there is a difference between average operator and central difference operator. First, here we have plus and there minus, and here is 1 by 2. So we have to take out average, meaning adding and dividing them into half. What do we call this here? Average, and we denote it by mu. We denote it by mu, right? Meaning if you want to find mu of fx, then this will be 1 by 2 and this will be fx plus h by 2. And here it will come plus fx minus h by 2, right? Meaning h by 2. So here what do we call this? This is called average operator, understood, students? And this is denoted by mu. It is important to note this. If I write this, then this is mu of fx. I've just explained this to you. So I can write it as 1 by 2. Its value will be e power 1 by 2 fx plus e power minus 1 by 2 fx. Clear, students? Now, so students, what will we do here? This will be mu and I will remove this fx is equal to. From here, this will come as e power 1 by 2 plus e power minus 1 by 2. So the value of this will be equal to this. Sometimes in exams, they ask for proof. Like they might ask you to prove that this is equal to this. We know mu square is equal to 1 plus del square by 4. What do you need to do? You need mu square. I will multiply by mu on both sides. This will be mu square is equal to 1 by 2 mu into. This is coming as e power 1 by 2 plus e power minus 1 by 2. But the value of mu is this. So we will put it here. So this will be mu square is equal to, again by taking this value. So this will be 1 by 4. This will be e power 1 by 2 plus e power minus 1 by 2 whole square, right? Now what we do is, this will be mu square is equal to 1 by 4. So if we square this, we get this square plus this will be e power minus 1 plus 2. So we will get the value here, clear. Now students, what do we do? See here. We need the relation of delta from mu. And what is the value of delta here? We know that delta is e power 1 by 2 minus e power minus 1 by 2, right? We need this term, so to get this term, we have to do square of minus here. So what I will do is, this is coming as minus 2 and plus 2. I will do this here, right? If we do that, we will get mu square equal to 1 by 4. Students, this and this, if we take minus 2, then we will get e inverse minus 2. So listen, it will be e power 1 by 2 minus e power minus 1 by 2 whole square. We will have these values. You see, if I take these two terms here, and this one, then ultimately when we open whole square of this will come. If I take the minus, then minus whole square will come. And 2 that we have here, what will come? 4 will come. Its value that we have is del, right? This will be mu square is equal to 1 by 4. And this will be del square plus 4 here. Clear, students? We can write 4 as I. Now we will multiply this 4, then here from 4 to 4 will be cancelled. So 1 will come and this will come del square by 4. So in this way, very easily we can prove it. And this type of question comes in exam. Moving on, sometimes based on this questions are made. How do we calculate mu of x square where h value is given 1? Students, we know that here, if you want to apply mu to any function, so it's like an average operator. So what we will do? X plus, here it will be 1 by 2 whole square plus x minus 1 by 2 whole square. Clear, students? Right. Here what will come? This will be the value here. It will be 1 by 2. It will be x square plus here this will be. X plus 1 by 4 will come, right? This value will be plus this will come. X square minus x plus 1 by 4 value will come, right? So here we are opening whole square of a plus b and a minus b. You can see that x is cancelled out with x. So we get 2x square plus 2 by 4. We will cancel it by 2. Then it will be x square plus 1 by 4. In this way, we can easily calculate it here. Before moving ahead with more concepts, I want to tell you, if you are preparing for the CSIR NET, IIT-JAM or GATE exam, then my books are available on Amazon and Flipkart. You can check them out. So if you want, you can buy them. Now talking about the next question, before moving on with the next question, there are some important relations which comes in exams. The relation between difference operator and differential operator, sometimes questions come in exam on relation of difference between differential and difference operator. So here we will use the concept of the Taylor series. We know that what is the Taylor series that we have. Look here. Here, students, fx plus h is equal to fx plus h, f dash x plus h square upon 2 factorial. Students, this will be our f double dash x, right? F double dash x plus h cube upon 3 factorial. This will be our f triple dash x, and like this way, we have this going on, right? Here we know that whenever we have d by dx of fx, we write it as d of fx. So I can write it like this here. See, here we get fx plus h is equal to fx. We can write it like this, h d of fx. Do you understand this, students? Plus this will come as h square upon 2 factorial. I can write this as d square of fx, right? Like this it will continue going on and keep on going. This is clear. Now what we will do, take this fx common backwards, so I can write it as shift operator. So now I can write this as e of fx is equal to, this will be 1 plus h d plus h square, d square upon 2 factorial. It will be like this, right? And this will come to as fx, clear. Here we have the series of e power x. If you have seen the series, it's 1 plus x square upon 2 factorial. So this is series for e power x. In place of x, we have hd. Now this will be e power of fx is equal to, this will be e power of hd into fx. Now what will come here? Its value will come, right? Now this fx and fx is removed. Okay, students, here this e is equal to e power hd is what we have. So this is what I will write it here. E power hd is equal to e. What is the value of e? It is 1 plus del. We have just seen the relation between del and e. So wherever we have this value given here, we can write it as 1 plus del. Now what we will do is we will take log of this here, as we have to find the relationship between d and del, right? Here on both sides I will take the log. So here on both the sides I will take the log of this. Now what are we getting? It will be log of e power hd is equal to log of 1 plus del. From this log, this e will be removed, then we will have hd. Here it's 1 plus log 1 plus x series. So here we will have x. Then what is the series of log 1 plus x we have? So listen carefully. Here log 1 plus x series is x minus x square upon 2 plus x cube upon 3, right? So in this way we have this series. So here instead of x, what's coming? Del is coming. So it will be del minus. This will be del square upon 2 plus del cube upon 3 minus like this. It will keep on going. Students, divided by this h, del is equal to 1 upon h, and it is d is equal to 1 upon h, del square upon 2, right? Plus del cube upon 3, right? So sometimes this becomes a question in the exam. So we can do it like this way here. Now let's move on. One more question is there that is known as a factorial notation of the function, right? And this is a very good concept that whenever we have any polynomial given. So like in this form, xx into x minus 1, x into x minus 1 into x minus 2, like this you have to explain it, meaning express it. So like this way we can do it here, right? Clear? So here this means x we don't call x power 2. This is x2, which means x into x minus 1. This is x3, which means x into x minus 1 into x minus 2. Okay? Meaning it's a kind of factorial. What is a factorial? If we say 4 factorial, what does that mean? 4, 3, 2, 1 will be getting minus. So this 3 times factorial is applied here, right? So here this will go backwards 3 times, right? This is 2, so it will go backwards 2 times. Its meaning is clear. Okay, now you are being told that we have a polynomial here, which you have to express in this form. Clear? How will you express it? You need to understand. So see, here we have a question here that says x cube minus 2x square plus x minus 1. So you have to represent this in factorial notation. Now students, what will I do? A, here x will be 3 plus bx2 will come plus cx1 will come plus d. What we have to do, find value of ABCD. First, let's open this. So here this will be x cube minus 2x square plus x minus 1 is equal to a, x into x minus 1 into x minus 2, clear students. Plus bx into, here we will get x minus 1 plus cx plus d will come. What we have to do, we have to calculate values of ABCD. So I will put this x equal to 0. I put x 0 here, this will be minus 1. From here, if we put this 0, 0, this will be d. The value of d we have here is minus 1. Now what we do is put x is equal to 1, right? We put 1. As soon as we put 1, then we will have 1 minus 2 plus 1 minus 1 equal to 0. We put 1, then this 0 will come as here is coming. So this will become 0. Here we have c plus d. Here 1 to 1 will be cancelled. This will be minus 1. And values of c and d will be minus 1. From here the value of c will become 0. Now next what do we do? Put x is equal to 2. Wherever x is there we put 2, right? So as we put 2, then from here the value we get will be 8, and we put it here. So also this will be 8 plus 2 minus 1. Here if put 2, then this will become 0. If we put 2 here, then this will come as 2 and 1, right? So this will become 2b. And if we put it here, then this will become plus 2c plus d. Clear? Okay, 8 will cancel out 8. So 2 minus 1 will be 1, right, is equal to, from here we get 2b and value of c is 0 and d is minus 1, right. 1 will come here. So listen, we'll have 2b is equal to 2. So we will get the value of b, which will be 1. Clear, students? Now what we will do here, we have to find value of c. Now we will equate both sides of coefficient of x cube. So coefficient of x cube on both sides. So here the coefficient of x cube is 1 and here the coefficient of x cube on this side will be a. So the value of a will be 1. Take the value of a, b, c, d and place it here. So the answer that we get will be, so the answer we get, it will be x cube minus 2x square plus x minus 1. Here we will put the value of a as 1. So it will be x. 3 will come like this, right? Plus b. What is the value of b coming? It is this. So this will come as this. Value of c is 0 and what is the value of d here? It's minus 1. This will be the value here. If you want, we can simplify it by opening it and then this value will come. So like this way, we can do it very easily here. I will try to bring some more questions for you. They are easy. You are being asked to prove that nebula is equal to del E inverse. So you have to prove it. First we will take LHS. Okay. I will take LHS here. Here if we apply nebula to any function. Okay, so what do we have here? It is fx minus h. Clear? You need to understand this, right? We know that here if we talk about this, it's a kind of identity operator for us. If this is minus, then we know we can write it as E inverse of fx, right? From here, the value that we will have, it will be coming as IE inverse into fx, right? So this is coming as nebula of fx. We know that nebula is equal to 1 minus E inverse. So what happened? Here we have proved it. If we want to prove that its value is this coming, right? The value of this is coming as this. If I can prove that its value is also equal to this, then work is done. It proves equal. Now if we have to prove this, so what do we do? Here we will take del E inverse fx. But I want to tell you the meaning of del that we have is E minus 1. You need to pay attention here because we know that E is equal to 1 plus del. Clear? So we will use this relation here. Students, wherever there is del, we will write this E minus I is equal to E inverse into fx, right? When this will come inside this E inverse, E will become I and this will be E inverse fx. Students, if we multiply this fx inside, then it will be fx minus E inverse of fx, right? What does inverse of fx mean? It will be minus fx minus h. We can do it like this. You will do this one the same way. Instead of del, you need to put E minus and then multiply it inside. Then the process will be same. Clear? Next question. See what does it says. The next question is find the successive difference of fx is equal to a, b, cx and sum of the first n differences. You need to calculate successive difference del fx, del square fx, del cube fx, del n fx. Then you have to calculate all the sum. Then what will be the value? This is an easy question. What we will do is we will find the del fx, right? So what does del fx means? Del a, b, cx, we will apply power of a and b, which is cx. Students, we know the value of this and what will we get? ABCX plus H minus ABCX, and what do we get here? Its value. Clear? Okay. So here if I simplify this a bit, as you see, I will write it like this: ABCX and BCH, like different powers minus ABCX, right, students? So what do we do with this? I will take out the common from ABCX. So we will get BCH minus 1. Is it clear? But students, we know that if I, this is what? This will be the value of del of fx. If I want to put del again, pay attention. If I will put del again, then it will be del square fx. So del is only applied here. This is constant, right, students? And if I apply the del to this, pay attention please, ABCX. Del will not be applied on this. This is constant. Del is applied on x, right? This will be CH minus. So the value that is coming, that is the same value, the del which was there was this only. I will pick this and keep it here. So from here we will get the value of ABCX and this will come back here. So these two will be whole square. This will be b power ch minus 1 whole square. You need to understand this, right? Students, if we talk about this in the same way, then if we talk about del cube fx, so this will be ab power cx and this will be bch minus 1 power cube. In the same way, if I talk about the nth derivative of this, so students, this will be abcx, then this will be bch power n will come. Now, what is this telling? We need to add it, all right. When we will add it, the value that we will have here, what will be the value? This will come as del fx plus del square fx. Like this way, it will come del power n fx. Clear, students? So as soon as you add this, what will you do? I want to tell you that what are the values we are going to add, right? First is this value, then this value, right? 1 we have this value, so like this, it will keep on going, right? We are adding all these values. So here we have AB power Cx, AB power Cx, AB power Cx, all are common. So take out the common, right? 1 we have AB power Cx here plus B power Ch minus 1. This is coming here and also here. This is also here, right? So this will be common. This will be B power Ch minus 1. We will take common. So here at first there will be 1 left. So here we have B power Ch minus 1 left, right students? So if I take out common here, this will come B power Ch minus 1 whole square. It will be left, this will keep going. In the end, we'll be left with B power Ch minus 1 power n minus 1, right? Because we took out the common, right? So here it is the n degree term. This is a geometric series we have, right? Whenever a geometric series is formed, right, I am writing here del fx plus del square fx, right, like this it keeps on going. And this is coming as del power n fx, right. What we have here, series is formed, we have geometric series being formed. Inside this we are talking about n degree term. So this will be AB power Cx and in here it will be B power Ch minus 1, okay, clear students. So whenever we have a series of this type, 1 plus r square and up to r power n minus 1. So here this will come as 1 minus r power n, 1 minus r. So this will be the formula we have, where the value of r is B power Ch minus 1, right? So this value that we have will be, so this will be 1 minus, and this will be students B power Ch minus 1 power n upon 1 minus B power Ch minus 1. Do you understand students? So here what will we have? We will have the value of this here. You are seeing that this 1 to 1 will get cancelled. So students, here we will simplify this. So this will be ABCX, B power Ch minus 1. If we simplify this, we will get 1 minus B power Ch minus 1 power n upon 2 minus B power Ch, right, clear students. So RPSC, which is for college lecturer, in that this question was asked in exam, clear. Moving ahead. So next question asks you to prove the value of del of log fx is equal to this. So what we will do here, pay attention, we will talk about del of log fx. Now students, from here, what will be the value that we will get? So when we apply del, it will be log f x plus h minus log. This will be fx. We have the value coming, right? What do we do here? When we will do this, it will be log of. Here we have its value. It will be log a minus log b, right? What do we have here? It will be log x plus h upon fx. Do you understand students? We have its value here. Here what we do? This log of fx plus h, can I write it like e of fx? It will be upon fx, understood? So this will be its value. We know here that the e, we have its value is 1 plus del, right students? So here I will replace this e with 1 plus del. From here we will have its value log 1 plus del into fx upon fx, right students? If we calculate the value from here, then this will be log fx plus del of fx upon fx, right? Now divide this fx separately, clear. So as you divide this separately, then this will be equal to 1 plus del of fx upon fx. So this will be our proof here, right students? In this way, you can easily do this question here. This question is for comment box. How much time did it take you to solve it? Comment and let me know, and how helpful is this series? Comment this and let me know. If you haven't seen my old videos of numerical analysis, check out the entire playlist here. If you are preparing for CSIR, NET, GATE, IIT-JAM exam and want to improve your general aptitude, you can watch my videos here and subscribe to this channel. Thank you very much to all. Thank you. Bye-bye.